And our final speaker for this session will be Matthew Gregoire from the University of North Carolina at Chapel Hill, who will be presenting CheckOut, a user-controlled anonymization for customer loyalty programs.
Hi, I'm Matthew, and I'll be presenting on CheckOut. So let me start by sort of setting the stage for the problem that we're trying to solve. So as a user going, as a customer going to a supermarket, the kind of interface that you satisfy is at purchase time. You provide a payment method, and in return, the retailer gives you a receipt for your transaction. And in particular, what we are interested in with this problem is when this retailer has a customer loyalty program. So at payment time, in addition, you also provide your loyalty account number, and in response, the retailer gives you some loyalty points and discounts. So this is good for the retailer because they want to incentivize repeat customers, and the customer obviously wants access to these discounts and loyalty points. But there are a couple of issues with this setup from a privacy perspective, in that the retailer can build a profile on customers' purchase history, and moreover, this surveillance by the retailer is unavoidable if the customer wants access to these loyalty points. And I also want to note that even if we fully solve privacy in terms of payment processing, which is a big area of research, this problem would still exist. And this has led to real-world issues that have been sort of explored in the news over the past 10 or 15 years. And the takeaway is that these loyalty programs can be potentially revealing, for example, sensitive medical information that you may not want your supermarket to know. And so there's a class of sort of resistance mechanisms to these types of surveillance termed obfuscation by Helen Nissenbaum. And this is a type of resistance mechanism whereby you try to render the data that this party is collecting via the surveillance. You try to render this sort of ineffective or useless. And these methods are very kind of grassroots and ad hoc. And there are a couple challenges that we are interested in this project. Importantly, we are in direct opposition to the incentives of the retailer. So if the retailer is interested in protecting customer privacy, then the tools to solve this problem exist and have existed for a long time. But we really have very little to work with in this setting. And in particular, what we want to do is we want to improve on existing grassroots kind of manual efforts and allow tracking of loyalty point balances. So a potential solution you could imagine is having some sort of anonymity set. So this entity would, at checkout time, provide the user with a random loyalty account number that the user then uses with the supermarket transaction, and in the end forwards the receipt back to this anonymity set, and then this entity will keep track of point balances and who owes whom how many points. There are a couple issues with this. The first one I want to mention is that there's a question of how we address malicious users, and unfortunately this kind of just comes with the territory. So any sort of system that sort of satisfies this interface will have the issue of, for example, a user could just lie and say, I've accumulated 1 million loyalty points in this transaction, and we have no kind of ground truth to compare that to. Or, for example, a user could just walk away at the time that they need to repay points. And I also want to mention that this that the system that we are introducing is particularly useful for loyalty programs that have direct correspondence between points to monetary value. But More importantly, the issue with the system just described is that we've just shifted surveillance from the retailer to this third party, and the exact same privacy concerns that we were worried about before still apply. So our goal here is to design a secure protocol to keep track of loyalty point balances, which reveals no information about purchase history to the server. So our contributions in this work are, first, we implement a point tracking protocol that's secure against a semi-honest server, and we implement one that's secure against a malicious server. And we'll discuss a portion of this solution in this talk. So we break a point tracking scheme into 4 pieces. So first, how do we register clients with our service? How do we process transactions? How do we distribute receipts for each individual transaction? And finally, how do we settle user balances? So our focus today will be on the transaction processing phase. So you can imagine an insecure kind of straw man example of transaction processing where, say, Alice is initiating a transaction and the server has a database of each user and their corresponding point balance. So Alice requests a random loyalty account barcode from the server and tells the server how many points she used in her transaction. And the server will add this number of points to Alice's account and subtract it from the barcode owner's account. And obviously, this reveals transaction information to the server. So how do we process transactions securely? And the core of the idea here is to separately mask each transaction. And so you see here that same x value, the number of points used in the transaction, is hidden in the exponent of a group element. And so the server can kind of do an analogous operation where it's sort of adding x points to Alice's balance and subtracting it from Bob's. And we can see the number of points is hidden in the exponent. And we also have this mask m that's chosen independently for each transaction. And as long as Alice and Bob keep receipts for each transaction, so they remember these values of m and x, they can later prove to the server that their balance was computed honestly when they reveal their balance in aggregate. So a simplified version of the transaction processing protocol is you see here Alice is sending a transaction receipt to the server, and the server is updating Alice and Bob's balances accordingly. And the server will sort of forward this receipt to Bob. And when we go to settle balances, each user will provide to the server their revealed aggregate balance and a proof that this balance is well-formed. And in particular, this is a non-interactive zero-knowledge proof of knowledge of the secret values in every transaction associated with that account. And so the server completes this protocol with each user of the system and then is able to handle payment settling from there. So I want to talk about our implementation results. So in the malicious setting, the computation time for most operations is on the order of less than 5 milliseconds. So this is less time than it takes to move your card from your wallet to the payment terminal. And the communication overhead is well under a kilobyte for most operations. So here we see kind of a summary of 3 of the 4 kind of groups of operations that I outlined previously. And you can see all of these are, in absolute terms, the performance is good. One thing I do want to highlight is that in the balance settling phase, for the malicious protocol, recall that we generate this zero-knowledge proof that the client is revealing the value of their account balance accurately. And the size of this proof scales with the number of transactions that touch that user's account. So the computation overhead for the balance settling phase scales linearly with the number of transactions, but this is an operation that you could expect to happen every month, 2 months, 3 months, and even a very high number of transactions on an account like 100, we still see a very reasonable overhead. So in conclusion, we have presented a protocol for private use of loyalty points that A, hides purchase history without cooperation from the retailer, and B, improves on existing obfuscation efforts by allowing users to accumulate loyalty points. And thank you, and I'm happy to take any questions.
Thanks, Matthew. I have already one question over here.
Thank you for the talk. I think it's a neat concept, and I see, though, that if a store were to implement this, then they lose out on the ability to see which targeted advertising towards which customers might be most effective. So I don't see the business sense that a store would want to do this. Is there another incentive that I'm missing?
Exactly. So, so if the business kind of loses this this targeted ad information, then from the perspective of this project, we would consider that a success because the retailer is not the one who's implementing this. This is sort of a grassroots, independent, third-party hosted operation. You could imagine an implementation that has loyalty point tracking for multiple different retailers, So kind of the thrust of this work is we've kind of put a wrench in the works of this one aspect of surveillance. Yeah.
So a follow-on to that, I think it's a really interesting question. So what will a retailer do? They presumably have other ways to do this. Why should we believe that this would be successful if more than epsilon of consumers adopt it? Isn't it inherently self-defeating?
So that's a good question. I think it puts maybe the. I think the focus is maybe a little misplaced if we if we say that, oh well, the retailer will just have another way of getting the same information, so we might as well not even try to circumvent this avenue of surveillance. So I think this is sort of one step towards more consumer privacy and consumer controlled privacy. And if the retailers have to come up with some other solution to get the same data, then so be it. And in 5-10 years time, you'll see a new presentation at PETS about whatever the new mechanism is. Yeah.
Cool. I also have a question myself. So I see that you have your GitHub link up there. So looks like there's a prototype of this. So and did you try? What's your experience with trying this out in practice? And do you have any plans to roll this out on a larger scale? And do you have any plans to advertise this to the general public?
Yeah, that's a good question. So we don't have any kind of grand ambitions for real world implementation. And the prototype that's linked here is sort of an implementation of all of the cryptographic aspects that would be necessary on the server side and the client side. But there's no kind of like Android front end or something like that. So it would require some more work to get it to that level.
Okay.
Yeah.
Yeah. Thank you so much.
Yeah.
Thanks, Matthew, and all the other speakers for this really interesting session.